Your agent runs 1,000 tasks overnight, and when the invoice lands, GPT 5.5 just cost you twice what Kimi K3 would have charged for the exact same work. GPT 5.5 is OpenAI's reliability anchor. Kimi K3 is Moonshot's open weights cost king. Today, I'm running them head-to-head to figure out which one actually earns your agent harness. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. Alright, so test 1 is cost per task, and this one bites hard in agent loops. Run 1,000,000 output tokens through your pipeline, and GPT 5.5 charges you $30 per million tokens. Every single call, no caching discount anywhere. At scale, that number compounds really fast, and it's the first place agent budgets blow up. I looked at the published API pricing, and Kimi K3's international tier comes in at $15 per million output tokens, exactly half of GPT 5.5's rate, and on cache, hits it drops all the way to 0.30 per million, a 10x discount versus a cache miss. I couldn't find any published cache hit rate for GPT 5.5, so that comparison only goes one direction. Kimi K3 takes cost, and it's not subtle. Half the price on standard output and a cache hit rate that GPT 5.5 can't match on paper. That puts Kimi K3 up 1-0, and the 2-to-1 output pricing gap is really the number this whole video is built around. I've been living inside these models long enough that a surprise invoice is basically how I find new pricing gaps. Has the output cost ever blindsided you mid-project? Drop it in the comments. Okay, test 2 is coding performance, and here's the objection I keep hearing. Kimi K3 is cheaper, sure, but if it fails on real software tasks, the savings don't matter at all. Terminal Bench 2.1 and SWE Bench Verified are the two scores that actually measure whether a model can close GitHub issues and write production-level code without handholding. On Terminal Bench 2.1, Kimi K3 scored 88.3% versus GPT 5.5's 83.4%, both vendor reported, so the same caveat applies to both. On SWE Bench Verified, independent evaluator Val's AI put Kimi K3 at 93.4%, while GPT 5.5's vendor claim sits at 88.7%, and independent runs put it lower, between 82.6 and 87.6%. So the evaluator setups differ, but the direction is consistent. I expected a closed OpenAI model to hold the coding crown, but Kimi K3 beats GPT 5.5 on both benchmarks, including a 5-point gap on Terminal Bench where the setups are directly comparable. That's Kimi K3 2, GPT 5.5 0. Test 3 is speed and latency, and this is where the cost story gets complicated. Your agent fires a request and waits 36 seconds before the first token comes back, which is 36 seconds of dead time per call, multiplied across every step in your pipeline. And at high call volume, that latency either kills your UX or forces you to rethink the whole architecture. So here's what the numbers actually showed. GPT 5.5 streams at 72.4 tokens per second versus Kimi K3's 38.7. So GPT 5.5 is nearly twice as fast once it starts generating. But Kimi K3's time to first token is 3.11 seconds against GPT 5.5's 36.19 seconds, a 10x gap that makes Kimi K3 way more responsive for interactive agent loops, even though it streams slower afterward. GPT 5.5 takes speed because raw throughput at 72.4 tokens per second is the deciding metric for batch workloads, and that nearly 2x streaming advantage is real money on long output jobs. That makes it Kimi K3 2, GPT 5.5 1. So right now Kimi K3 is ahead on cost and code, GPT 5.5 just clawed one back on throughput, but context and output limits are still on the table. And if your agent needs to generate really long outputs in a single call, that next test could completely change the unit economics you just saw. And then deployment flexibility decides whether any of this is even accessible to you. Test 4 is context and output limits. Your agent is generating a full codebase refactor or a long-form report in one shot, and it hits the model's output cap mid-task. So now you're chunking, reprompting, and paying for overlap tokens you already generated. At 128,000 output tokens, that ceiling arrives faster than most people expect on big code generation jobs. Both models sit at roughly 1.05 million context tokens, so that's a wash. On max output though, Kimi K3's vendor spec claims up to 1 million output tokens versus GPT 5.5's 128,000, which is 8 times more headroom in a single call, and I'll flag that third-party hosts often cap Kimi K3 output at 128 to 131,000 tokens in practice, so real-world results may land lower than the vendor spec. Now, the 1 million output token claim is vendor reported, and third-party hosts often enforce a 128K cap anyway, so the real-world gap may be smaller than the spec suggests. That said, the vendor ceiling still matters for self-hosted deployments where you control the config, and even a 2x or 3x practical advantage over GPT 5.5's hard 128K limit is worth real money on long-form generation jobs. Kimi K3 takes context and output limits because even with third-party host caveats, its ceiling is at least as high as GPT 5.5's, and potentially 8 times higher when you self-host. And that brings the score to Kimi K3 3, GPT 5.5 1. Test 5 is deployment and modality, and the failure mode here is a vendor lock-in problem. You build your agent harness on a closed API, the pricing changes or the endpoint goes down, and you've got zero fallback because the weights aren't yours. So for teams that need to self-host for compliance or cost control, the open versus closed question is a hard blocker. Full stop. Kimi K3 is open weights under a modified MIT license, meaning you can self-host it on your own infrastructure, and it also accepts video input on top of text and images. GPT 5.5 is fully closed, text and image only, though it does run on Azure OpenAI and AWS Bedrock, which makes enterprise procurement straightforward if you're already in those ecosystems. Kimi K3 takes deployment because open weights plus video input is a bigger flexibility win than Azure and Bedrock availability, especially for teams that need to own their stack. And that brings the final score to Kimi K3 4, GPT 5.5 1. Okay, so where does GPT 5.5 actually win? Raw streaming throughput at 72.4 tokens per second is nearly twice Kimi K3's rate, which matters a lot for batch jobs. Generating long outputs fast, it runs on Azure, OpenAI, and AWS Bedrock for easy enterprise procurement, and its LM Arena blind-voted ELO of 1480 signals solid general-purpose chat quality. Kimi K3 wins on pretty much everything else. Output tokens cost half as much at $15 per million versus $30. Cache hits drop that all the way to 0.30. Terminal bench 2.1 goes to Kimi K3 at 88.3% versus 83.4%. Time to first token is 10 times faster at 3.11 seconds, and you get open weights plus video input that GPT 5.5 flat out doesn't have. If you need bulletproof JSON adherence, raw batch throughput, and you're already on Azure or Bedrock, go GPT 5.5 and pay the premium. For everyone else building agent harnesses on a budget, Kimi K3 is half the price and genuinely beats GPT 5.5 on code, and that gap doesn't close just because OpenAI has a better brand name. One thing the docs don't flag: Kimi K3's 1 million output token ceiling is a vendor spec, but most third-party API hosts default to a 128K to 130K output, capped by default, so if you're routing through a third-party provider and not self-hosting, you may never actually see that 8x output advantage unless you explicitly check and override the host's default limit. Now, if you want to see how Kimi K3 stacks up against another open weights coder, I ran the same kind of breakdown in Qwen3 coder versus Kimi K3, which is already up. And the cost story there gets even more interesting because Qwen3 coder actually trades blows with K3 on SWE bench at a different price point entirely.